You know, like, oh, yeah, you do that. You do that. Okay. Okay, so some of you we met Nathan and like we recognize each other and like know him. So I can do better. He is the one who recognized me from the back of my head and on the back. We know each other for a while. So he's also like a volunteer at
Yep. Web apps, little web app attacks, all that good stuff. I believe I'm streaming now. I don't really know. Let's see here. Pull up my Twitch app. Okay. Yep. There you go.
It's Friday.
No,
I read your comment.
No, I read another thing. Also, your language affects your ability for see color.
Okay, guess go ahead and get started here. Hello, everyone. Of course, today we talk about web application attacks. We'll talk about this today and get right into it. And I am currently streaming on Twitch too. I don't think anyone's on there, but hello everyone at Twitch, and I put it in the Discord. It's my one I have. So if anybody starts getting in there and starts chatting, I won't be able to really see that small screen or really interact with them. So if anybody else wants to interact with people on Twitch, feel free, go right ahead.
Actually, a pretty regular chat.
So to start out with, just kind of want to go over general web stuff, right? What's parts of the URL? Like you gotta really understand each part of this. So at the very beginning, you got your scheme. This is HTTPS. Of course, we know that's secure. Online these days, you really don't see HTTP much. Of course, that's basically the difference between using port 443 and port 80, which HTTP is port 80 and HTTPS is secure one using 443. The www that's seen a lot of times, that's all it is a subdomain. A lot of times the www is starting to go away. I know that was something that was originally always part of the website, and in fact most places you can still put the www. It just okay, we brought you to our actual domain, which this is your domain. This is a TLD, so top level domain. That's your .coms, your .orgs, the .edu, gov, all those things, but also the .co.jp, how I understand it, with that being the Japanese country code for that. Of course, you don't really see this often whenever going to commercial sites, but you can put a colon and put in a port. Other things include your path. Now, whenever looking at a router and things like that, when it's HTTPS, they say if you're looking at logs, the company will log up to this point usually. Because the external router that you're sending this to will need to know, okay, where are you going? It doesn't really need to know what part of the website you are going to, because that's actually a secure communication between the website and yourself. But to get you to the front door of that website, that's where the router would need to know that. So you can actually see that. The query stream separator, a little question mark, and then the query stream parameters, the name equals whatever your name is, your ID number, whatever it is, different things like that. We'll actually look at this closer when we start talking about cross-site scripting, especially the reflective sort of cross-site scripting. And then finally, through this last part called fragment, this is basically like the hook into the specific part of the website. Like we need to see, say there's an article with a couple of different things and they have a history part that's halfway down the page. You can actually add in the link as long as the website has that hook in there. You can add in that fragment part at the end to say go directly to the middle part of this website where the history of the article is, or many different things. Some HTTP response status codes that I thought were more important than others. Or actually, here's the grouping right here. The 100 series is informational stuff. The 200 part is the successful response. Redirect messages from 300, line errors from 400, and of course server errors in the 500. What's this one? Oh! Thank you. That is the startup music that I started playing so it wasn't completely silent in here when I got here. And I just totally... I have tinnitus where I always have a ringing in my ear, so I have a habit of ignoring sounds.
I do that too without the
Yeah, and I have loud kids.
Is that where the tinnitus comes from?
It was more from the military, but thank you, Marine Corps. No, Marine Corps was good. Working around a lot of jets, not so good. Yeah, thank you for pointing it out because, I totally tune out that kind of stuff, as you could probably tell. Okay, let's see here. Actually, go back. All right. Those are the grouping and the codes to know. Of course, these are probably the ones that people have seen the most. 200. You got to the website and it's showing on your page. You probably won't see that whenever actually going to a website because you got the website. It's not going to show you the error code. But if you looked at the actual the console inside of the web browser, you'll see that the code for that when you receive the website was 200. 404, I think, is the one that people probably notice the most because it will actually show you on the website, hey, this website is not here. It is not found. So you get a 404 error. And of course, internal server errors for 500, and then permanent / temporary redirects 301 and 302. Sorry, the camera here is pointing up. Yeah, definitely.
You said that 404 is when the website is not out. Would it be more accurate to say that the page is not out?
Yes,
Yeah.
yes, that is.
You wouldn't get any response if the site.
Correct. Yes. No, you are correct. It would be more accurate saying the page is not found. Yeah. Thank you. So we get into the attacks. We're going to start out with forced browsing. Some might think about IDOR attacks, which is the next slide, but the forced browsing and IDOR are slightly different. I have a little simple website here. I have just a picture. Have different links, and they show you those links. These are kind of the links that people are expected to go to. But on a web page or website, there might be pages that are not shown, and maybe an admin portal, admin login, different information, and that's not. There's no direct link to click on. when there's no link to actually click on, but you actually go to that page, that is considered forced browsing. A couple of ways to do it. Different applications, Durabusters to find different directories that are part of the website. Uh, FFQF is it fluff? Like, yeah.
Plus fashion cool.
Yep. Buzz Faster People. That's what it stands for. This one right here. That's a GitHub website. The Daniel Mesler sec list. Sorry if I say that incorrectly. But it has just a whole ton of lists, password lists, directory lists, common website names that you can put in different applications just to scan through to see if you find anything. And then robots.txt, that is just a text file that is meant for crawlers on the internet that are checking each website. And if that crawler is supposed to look at that file, and it will have like things that say disallow, so it doesn't want those crawlers for the search engines or whatever it may be to categorize or reference those web pages or store those. But it's just basically a sign. So depending, like those crawlers could ignore them, especially if it was a threat actor's crawler. And of course, as humans, we could go directly to it and look at it and then see if those are sites that we want to visit. And of course, if the website has a browsable directory. This is kind of what I was talking about with the robots.txt. This is kind of how it would kind of look like. Let's say this is the links that you saw earlier that we were saying that could allow for the robots.txt. But then there's WP WordPress dash admin site, admin.php, and email. So those are areas that we're telling the robots not to go to. So if someone's saying don't go there, if you're attacking it, it might be a place to go. And then of course this right here, browsable directories, not really seen as much these days with websites. But if the page is not found, this is one of the things that was done before, where instead of giving the 404 error, like, hey, you would not find this page, you could end up in a directory, like to show exactly what web pages are on that system. Again, I don't see this very often, but I wanted to put that up. I actually remember seeing this when I was in elementary school, when I was browsing websites before. Not much these days.
Oh, I saw that last week.
Oh, you did? Oh, man.
It was someone sent me something to download and upload from a client or something, and then for some bizarre reason they did it in a directory like that. And it's just like
Intentional and stuff. It's not as common anymore. You used to do that.
Yeah.
There used to be a feature, I don't know if it's still there, where if the web page is set up correctly, you can actually go into the browser and upload directly. Maybe that's the thing that you're talking about.
Mm-hmm.
Like within file and like website or something like that, that you can actually push the file.
Mm-hmm. Yeah, and some people just might turn this on intentionally, but to help people navigate around their site. But this is something that could be used against them because of, like, what if they don't want people to get into these different either files or directories or whatever it may be. So on to insecure direct object reference, IDOR. So what's different between force browsing and the IDOR? Well, force browsing, we use lists, like try to figure out exactly what it is. IDOR is more about patterns. What pattern do you see amongst things? Like you can use numbers, short strings, dates, other predictable values. And here's where I put the query string again and put ID 1. Hey, what is ID 2? What is ID 3? Like, is there those web pages out there? I put this for example. see, 1775. Just FYI, like I was saying, I was Marine Corps, in Marine Corps, however you want to say it. But 1775 is Marine Corps birthday, so that's why I started with that. But then 11, 12, 13, what's 1775, 14, right? Then you got names: Washington, Adams, Jefferson, Presidents, Madison. So predictable things. This may not look too predictable right off the hand. And in fact, I wrote this slide so far back, I can't even remember what this is. I do know it's base 64. So you run, I think it's like 5 A's, 5 B's, 5 C's, but it's all in base 64. So you take this, put it into CyberChef, see what it is, and you can find the pattern. It is really easy to find once you change it from the base 64 into the normal text. I don't even know what the last one is right now, though. All right, moving right along here. The command injection. This is an issue where the code inside of your website might have it where it will take a user prompt and it doesn't sanitize it. And that unsanitized input is fed directly into the server. So where do you find this? Forms right in the URL. You put it directly in the URL, possibly through the cookies or any other spot that users are able to do input of any kind. I also wanted to point out there might be blind injections. It's possible that say you have a form or something that has a command injection, and you put in the data and it actually works on the machine, but it doesn't return what just happened on that machine. Like something happened, but you don't see it, so you're blind. There's ways to work around that. I put this one up here right here. This is a ping for doing it 4 times with an I for interval. Linux command, not Windows. I don't know what this would do in Windows. I don't even think there's a C on Windows. I think they use N for the count.
Hit WSL. Stop it.
Yeah. But see, this one with an interval of 5 seconds for each one. So let's say you believe you have a command injection and you enter in ping at just the regular one-time ping, and then the website just returns back quickly. Maybe it loads up just fine, and like, okay, let's try making this a longer ping. So you make it 4 counts of 5, so we're like 20 seconds. So instead of instantaneous returning back for the website, now you're waiting 20 seconds, and after 20 seconds, oh look, the website loaded after 20 seconds. So I know something is happening in the background, but I can't tell what it is. Like I know that the ping worked, but I just don't see it from that way. I can tell by the time it took the website, but I don't get a, say if you type in ls, and it doesn't actually write out all the files. Oh, ls for Linux is to list the files and directories. But let's say sometimes if you hit ls, it will actually list those files. But it might, for the blind, won't get those files. But there's different ways. Okay. So I went ahead and put this simple code up. Thank you, ChatGPT. Right here is the part to really get the look at. See, we have echo whatever the user input, and it goes into this variable right here. Here is the system command, which basically says, take whatever this variable is and do it. Well, actually, first it says echo. So first off, whatever, this is a command to repeat what is said. This particular website, which I have on that Raspberry Pi, so we could actually look at it as well if you want, will say, hey, put in your name or whatever, and it says, and it will just echo whatever you write inside the form back to you. So instead of what you'll do is put in, say, hello or whatever word you want, and then for Linux, you do a ampersand ampersand, which will be, that actually tells the terminal, hey, do this, echo whatever, but NN means also do whatever this command is. So put in hello, NN, ls to list your directories. You got all your directories. Or NN, delete root. Just destroy their machine. Yep. So on to cross-site scripting. There's a couple of types of cross-site scripting. Well, there's actually more than this, but these are the two that like I kind of know best and I'm going to go over. What are some others other than stored and reflective? Union and I don't know. Anybody else know any other ones? No worries. I know there's more than two. Not the best at this, but this is what I know. So cross-site scripting attacks are, and they are attacks that are focused towards the end user. It might be uploaded on a server that's and also using the server, but ultimately they are attacking the end user that's visiting the website. Of course, it exploits the vulnerability of the server. And the server, I kind of wrote this wrong. Like I said, server saved through malicious code. Yes, that's true for stored, not reflected. And we'll get into a little bit more details on each of those in the next couple slides. Normally using JavaScript whenever you store whatever sort of code. Of course, you can use HTML as well. My example is using JavaScript. And of course, server delivers it to victim. And this last one, the whole reason why cross-site scripting is so bad is because it exploits the vulnerability, like our trust. Like, say we go to a website one day and it works just fine, and we start going to it normally, and we trust that website not to give us a virus. Well, if it has a vulnerability with the cross-site scripting, like we could go to that website later on, and it might, in fact, upload something to our machine that gives us a virus. That's why it's one of a pretty it could be affected to end user. So, stored cross-site scripting. My cute little graphics, mostly made out of icons and stuff. But of course, we got this wonderful black hat hacker. Make sure I put the black hat on. It uploads it to the server. So that's number one. And then later on, you have the victim on their machine. They connect to the server, and because that stored cross-site scripting has been saved on that server machine, that's it's persistent on that server machine. That other person could come at any other time and connect to it, and it would download to their machine. The stored cross-site scripting, this is an attack that is very random. It doesn't really target any one particular person because the threat actor wouldn't really know which people are going to a particular site. I guess they could possibly try to direct people to that site that they're targeting, but they're going to get a whole bunch of other people as well. And here we go. We got ChatGPT code again. Just put the top part here where, see, at the very top, you can see the file name that is pulling from, the message.txt, and they would have a basically posting a message to that file. So you just add in hi, hello, script alert in parentheses, XSS, that make a pop up on your machine if once someone else goes to that site. But that part saves it into the TXT. And then down here, you have for each where it is just outputs directly. It doesn't sanitize anything, so there's no sanitization going in, and there's no sanitization going out. So a double whammy for vulnerability it causes this stored issue here. Any questions for this one? Oh, yes, Peter.
Do you remember in the early days of Twitter, you had a bio, and you tried job, decided to manage that, and then get someone to go to your bio, and then run JavaScript on there, this one.
Mm-hmm.
That was when it hit me, like, what something names.
Facebook. I mean, MySpace before that, yeah.
Mm-hmm.
You know, I like, we was there, like, I had to become not his, like, MySpace page, because people could do that. I didn't.
Yeah. Like some famous ones that are known that people in this room have been affected by.
And then you had a thing at the time where you could change your address on the website. And then you get a customer service agent, and it's then secure that so that your profile, they would then load your address into their browser, which will, and it made it sanitize it. It sanitize it. And then you have to now then run on the service agent. The fact that the disaster was your address was specified wrong. You didn't get much malicious whatever. People were like using telephone address, but it's not. But you could have that.
Yeah, like I
So that was made it run JavaScript.
and it's cross-site scripting. Like we know exactly what causes everything, but it seems that it continues to be one of the things that are the top OWASP. I don't even know what OWASP stands for, but it's basically website threats, the top ones that have been out there. Anybody by chance? OWASP.
It's an open web app security project. Open source web app security project.
Yep. So on to Reflective. So Reflective is a bit more precise. Like it can directly target someone. You got your black hat hacker, your threat actor, sending an email or something with a link to trustedsite.com, whatever, with the question mark for your query, and then equals, and then put in the towards the end the vulnerable part where they directs them to the trusted website. So the person that receives that email, they'll say, "Hey, trusted website. I've been to this place. I trust this website." They don't understand that that website does have a vulnerability now, and that back part of that link has the query that goes directly to the part where it's vulnerable and sends them to, that will redirect them to a completely different site that ultimately could infect their machine. So yeah, they send it directly to someone. Once that person clicks on that link, it goes to that website. It hits that vulnerability for reflective cross-site scripting, and then comes back down to them. And then whatever that they're asking for, let's say maybe maybe it sends them to a website. Maybe it just says like the cross-site scripting attack might just say, "Hey, give me all your cookies, all your session cookies." Maybe this is a Starbucks page or some place where you buy stuff.
Like a mirror of a legit website.
Yeah, well, like it might just send this person their session cookies, so they now have access to that website as well, because the server, it's going to do what the link asks, because it's going to be the script is going to be part of the link. If the link says redirect me to another site, it's going to redirect, the server's going to redirect you to another site. If it says give me your session cookies, it's going to do that. It's just going to, because it seems like it's coming directly from this machine, but it's just a link that was clicked on from there. And then, of course, goes there and receives whatever the threat actor asks.
If we're gonna go into this in more detail, we can
Please,
tell me that. But I wonder like how much like cores plays a part of this, like if you're on like the back end, if you're on the website end. Because I know like there might be legitimate reasons where you're gonna want to divert traffic. So let's say you're setting up the tech for troops.com, and then you have a login.tech for troops.com. That's a legitimate way that you want that to work. But you might have the browser's core might be so strict that it can't read the cookies from the original subdomain. Because I can tell you that from experience, but that's a nightmare trying to get all that.
SSH like certificates, like they don't like I think they recognize like domains and subdomains separately. At least what I got.
Yeah, there's and there's actually different, like this gets a little bit further than I'm too like what I feel like I'm confident about. But I do know that there are different protection steps that a person that's in charge of a website could put, and there is something about like setting it where don't go outside of it or things like that. You might know better.
Yeah, so like I can't remember what core stands for. It's like I know it has to do with cross-site scripting because it basically tells the browser as the website saying these are the domains that I control, and everything coming from these domains can see. So the default is the most the longest form of your URL. So if you have just textbooks.com, that would be it. But then if you do login.textbooks.com, that'll be it. So then you can't read anything from the textbooks that's in the original domain. And so if you're like me and you have a subdomain of a subdomain, then you start getting into even more complex stuff. The servers are on different places. You can't control the size. Yeah. So I was curious like how, because I know like part of this is like on the browser, because the browser takes care of a lot of that security for you, but you can also port the browser. And so now you're in a situation like as the web server and as the browser, like where does that trust start to it's a hard problem, and I always struggle with it.
Yeah, no, as we go on and on, like there's, like you said, a lot of other sort of protections that are out there that keeps cross-site scripting from happening. Yeah. Oh, so go over this real quick. Vulnerable website. Just basically, again, no sanitation when it comes to user input. It just gets what is given, you put in the name. And of course, this application is supposed to be like echoing out, hello, whatever your name is. But it might say, hello, here's a pop-up for an alert, or I'm now sending your cookies to someone else. And things like that. Hey, basic SQL. The what? Oh, I tell you, SQL. I'm not. This is probably the part where I have the most to learn, but I've done a bit with it. So some things about basic SQL, structured query language. The attack is, of course, towards the database. It attacks the supporting database. Of course, the vulnerability is in the code that directs you to the database, but SQL injections are ultimately trying to get the data out of the database that it's referring to. Basic statement for SQL generally has the verb, source, and redefines it, like the refinement section. Verb like select, select all users, select uh, only Tom, select admin from source from whatever database, test database, user database, whatever it might be, and then find that you could actually also put and is an admin or something like that. And then, of course, right here, the vulnerability for this one. You got the SQL where it's select star from users. So users being the table where the username equals whatever that username right there, the second one that's highlighted. That of course is a variable that the user gives it up at the very top on line 4, and then of course the password on line 5. Of course, in this particular instance, you, the vulnerability, you could actually comment out the password where when you get to the login screen, you don't even need the password. Because there is, again, no like checking and sanitation when it comes to those inputs. So, yeah, injecting the different scripts. End users control the input. It can be malformed. A number of different inputs that can be used. I did not put the pound sign up there. Sorry. Include a pound sign up there, pretending. Or a number sign, pound sign. Hashtag, yes. For different things. And here's one way to do it. So select file name from table name where owner equals Alice. And then, so this highlighted yellow part is what the end user would be able to put in the website. Like let's say it's only meant for the name, right? So username and password. But instead of just putting Alice or Bob or whatever or admin, what the threat actor would do is in the field put Alice, comma, or A equals A. And this is the last little part right here, and the first part is actually just part of the website code. All the thing that's highlighted yellow is user info. What that will do is say, search the table for Alice or anything that's A equals A or 1 equals 1. It is, so it's a true statement no matter what. So everything that comes through, it's like, okay, give me everything basically because true equals true. Every time it's going to be true. It's going to provide everything, if that makes sense. Of course, right here, next one, this little dash is a way to comment out the rest of the code. And then, like, so the password part is not even asked for. It comments out that part. I actually, when my application did not get the dash to work, but the hashtag worked for me. So like I did admin, comma, hashtag, that seemed to work whenever I was making my one for the that's on the Raspberry Pi. And of course, SQL Map is a program to help you search for these kind of vulnerabilities. Whenever using SQL Map, always use a valid link. Don't try to put in your own vulnerable code right here. You put in what would be the correct way, what the website was actually intended and expected, because that's how SQL Map works. It will put in the parts that does the injection for itself. And then when when using SQL Map, put the URL that you're using in quotes. My teacher said use single quotes because, like on a Linux box, if you use the double quotes, those will actually still pick up like a dollar sign or something like that and think that something is a variable. If you use a single quotes on the Linux terminal, that will say, hey, this is strictly just text, no variables or anything. So when I learned it, the teacher said use a single quotes. Hey, any questions? Yeah.
What are some ways to mitigate,
Just a lot of it's from my understanding is data like what was I say? Filtering, like making sure the user input is filtered. Make sure that there's actually libraries out there that you put in the code to say check this input string for any sort of anomalies to that it shouldn't be there. Also, you can just outright ban certain characters. I've seen on websites where down at the bottom they'll say like special characters that you can use. And when I did my little project in school, I just banned all special characters from my password, which is not the best way to do for passwords, but you know, I, I'm still learning myself, but I just know a little bit here.
And I think that it's you know, it's buying stuff.
The what?
When you find a question,
Yeah,
someone with a last name,
they're going to be mad.
you know,
Oh, yeah.
Yep.
the school procedures as well.
I mean, adding on to that, like, I know that for the Django project, for example, there's a project-wide setting that you can make it so that you just escape all special characters, for example, like HTML stuff, but they kind of, so they're depending on the software you use, like, that's probably already baked in. For example, like, if you're using, like, Django forms and stuff like that, it's supposed to, like, by default, escape users. You have to go out of your way to, like, unescape the special characters that can cause establishment.
see, that would mess me up, because I'm always assuming that I have to sanitize it myself, but I would double sanitize it, which I have done before.
Yeah, you
I
don't.
did not
Yeah,
realize.
that's probably, yeah, sometimes like, I think the caution there is like, you like, sanitize once, but sanitize twice, but undo the first sanitizer.
Yeah.
So that's like one of the things that you have to read, like, specific documentation of the very specific version of the framework that you're using, is what they did.
We can mind going back.
Yeah, definitely.
One of the, or one more, the one where you had the code.
That one?
So one of the other hard lessons that I've learned is like when you're writing something like this, to explicitly call out the column that you need. So it's kind of like the same concept of the least privilege principle. So you probably don't need everything from the user table. You only
Yeah,
need
probably not select one.
Exactly.
The other one is to make sure that the user that is connecting as is extremely limited in what you do. And the other one is that if you're only looking up the user, you put it on the limit statement so that you're not returning everything. Not only does it help your performance, but it also helps in attack.
I think there's a way to like restrict like admin attacks, admin like accounts, like you can't access it from there, you can only access it from like.
Yeah, specific IP addresses. Yeah. So it's like MySQL is really nice that way, where you can bind the connection to an IP address. And so especially if you know the IP address or what you're hitting, and the MySQL server knows the IP address you're coming from, you can also limit it so that it can only.
I mean, people also do that because the SQL server is usually in like a different like IP address from like the web application.
Yeah.
Cloud is that.
Yeah. That's nice.
Cloud is great. Cloud is great. We gotta like cloud guys, expansibility. We should get on AWS on that.
Oh, so for the cross-site scripting code that you had up, it said no sanitation. What
Yeah,
kinds
like-
of things does that get around? Or what is,
Oh yeah, like basically all of these node sanitation. Like anytime the user can input data that needs to be sanitized. Basically, don't trust the end user, like because one of those end users could be a hacker. That's In fact, it reminds me of a YouTube short. I don't know if anyone's seen it, with a programmer with their little bucket, and then the hacker with all the shapes, and then each bucket has a little spot to put it. You know what I think you all do. It was like a circle block that goes into, or a square block, I guess they start with, that goes in square hole. The programmer's like, yeah, good, good. Circle block, oh, that goes into the square hole. They're like, what? Like a rectangle block, that goes into the square hole. And the programmer's like, oh no. So yeah, you got that user input doing things that is can be done, but not the original intent or what the programmer meant for it to be done.
Okay, so
I
I'm
know.
sorry, go ahead.
when you put no sanitation into that code, is that, I mean, is that a comment, or is that?
Well, that's a
part of the
comment,
code?
but yeah, that's the issue with the code, that there
Okay.
is no sanitation for that user input.
Okay, so the attacker can't, I mean, the attacker can't really control that, at least not.
No, they can't control what the code is actually currently have, but without sanitizing that input that's going into that program will do whatever is said. Um, this particular program is meant to be a username and password, and then the programmer meant like to put just the username and just the password, and then it will look it up on that database, and then return like, oh, you were able to come in, or oh no, that's not in the database, you failed. But the way this is written, you could put in a comment, like make SQL also has the ability to comment out sections, and the username, that's what comes first. The second part is the password. So what the threat actor, the hacker would do is put in whatever sort of garbage as the username, and then actually no, it would actually have to be an actual username, put in admin, that's usually in the list, and then comment out the rest of it, and then it's basically commenting out anything about the password. That second part that asks for the password is like, nope, you don't need that, and so it just lets the person.
That one though, you can mitigate that from the server side. You can just disallow that from happening.
Yes, yes. Yeah, like, but in this case, with this code, like, no, this is bad code. All of this is bad code.
Okay.
Like, purposefully built to be bad, so to show the examples.
So I'm kind of wondering, like, for these different application attacks, what kind of things is the attacker prepared before unleashing one of these attacks? So they would be prepared and just try to live.
Well, like, I know, I'm thinking scanning, because I'm thinking like Burp Suite, they have a scanning tool to scan for this kind of things. So, and what you would do, the threat actor, the hacker, they'll use that on the whole internet or a part of it. Like they'll just start scanning randomly, or if they want a particular target that they're going after, they'll scan that website and start trying to find anything.
So have you guys had much success? I haven't tried it myself, so I'm not you guys like when you guys run Burp Suite on a site that's hosted behind Cloudflare, like how successful has that been?
You know, I've ran Burp Suite a few times, but I don't really know if it had Cloudflare, so I don't really have a good
Because
answer.
Cloudflare is like one of the things for Cloudflare to do is like stop these types of things. And that's a very popular service for other reasons like AI crawlers or like people who don't want their website getting like DDoS if they host it.
Well, Burp Suite is like, typically you're gonna see that like being used on user level, you can
Yeah.
interact with it.
Yeah.
So if you're doing like a web pen test or like a security assessment, you're gonna see direct feedback, which is like crawling or like a port scan.
Yeah.
So you might get rate limited if you run like a crazy scan or something, just turn the goods down. But
Okay.
it's not gonna be like, I mean, you can get around platform in map.
Okay.
Rate limit is like the biggest concern.
Yeah, that's what I was wondering. So that's okay.
Thank you, Alan.
So you want to do, so you want to know like what SQL stuff they're using. The one uses double dash is, and one uses hash is to connect with it.
Yeah, okay, then like it's just like, you know, you could, I guess, use whatever students will with whatever, but I'm more and really interested in like, okay, well, what kind of information is like the hacker gonna see like that like the green light's gonna go off and be like, oh, awesome, like I wanna go like after that, so I'm curious about that.
That I can answer that. So can you go back to the
Yeah.
directory listing? So back in the day, one of the reasons why this directory listing is no longer as popular is because at the very bottom it'll tell you the server that it's using, like the program, as well as the version. So if you know that, you now go to the websites or the website program like GitHub repo, then find out like if this is the latest version, you don't think it is, and then look for any vulnerabilities that have come out since then. So once you know that, then you're like, okay, now I can go to this website. Now that I know all this information, and then I can start putting the pieces together. And it's a lot of it is, I'll be honest, boredom. A lot of people get bored and they're like, oh, I wonder what I can do. There are definitely, very intentional, very, driven, especially in the politics, what it is, very directed at bringing things down. And they will be very intentional about this, and it goes beyond the people who become very hostile. And so that's why a lot of stuff like this has to, you have to hide it or obfuscate it.
What is attacked is really dependent upon the person that's attacking it, or is it a person that is part of a bug bounty program and they went to HackerOne and found specific places where they want to start trying to attack that particular website to look at? Is it a group that's just doesn't like what the government's doing, and they look specifically at government websites to try to deface the website somehow? Or is it someone that's trying to attack companies like North Korea that constantly are trying to get like money that's lock down data to ransom with ransomware or whatever? So it really depends on the threat actor and what their goals are, what they go after.
You could use the cross-site scripting to sort ransomware on computer.
Yeah. Like
I'm trying to say one.
Thinking
If
about
those are
the
flagged,
parts
they
that you
can
have.
fall back to like something you posted.
You can go back to the correct arrows again. You can go back to the
Like,
start
yeah,
menu.
yeah.
I mean,
So it depends. Like there's a lot of yes and
I mean,
well, so I mean, the way that you would do that,
Austin.
or the way that you would do that is like if you have that directory listing, or if you're looking at this website and you know that he's pulling in a specific JavaScript file,
Yeah.
you could go into the server, replace the JavaScript file with the exact same name, but with your particular payload, and then that will run on the computer. Depending on the user's browser, if it's old, that might have a depending on self vulnerabilities. So you're counting on a lot of money. But given how popular a website is, like if you did,
Popular JavaScript framework.
or that too, yeah. So you have Wikipedia would probably be an example. Like if you found a way to insert like a malicious file, I mean, you're looking at millions of people. Out of that million, you would probably think maybe 0.1% might have a vulnerable computer at that point. And so it's a better thing.
I mean, think of like the old days, like before, like AdBlock became popular. I don't know whether people are using it anymore. One of the reasons people use AdBlock is because of a random JavaScript that's just downloading random files to protect your computer. You're just around with them. They probably back in the days when Internet Explorer was so popular, but like Chrome and Firefox throughout the time, like it's usually because of some stupid ad that like downloaded something in the background of your website. Like then you went to didn't click on anything, but just the fact that the ad loaded and there's like embedded JavaScript as part of the ad that downloads some shit on your computer now.
So there's like sites and browsers like disabling the JavaScript to prevent that happening.
Yeah. Because JavaScript is just so popular.
George, that still is an issue.
The JavaScript shouldn't be doing as much as it should be. That's the core of the issue.
It was made in a weekend.
it was made in 1 weekend. Is
I
that?
have memories for myself.
Wow.
Was it Brandon Ike back when it was at Mozilla or something?
yeah.
That was, yeah.
It was just something to get through.
Wow, I didn't even know that. That's awesome.
So I guess it's named after Java.
Yeah, yeah. It was just like, oh, we'll just slap this together, like the JavaScript. Wow, I'm learning it. I'm standing up here.
But also like back before like cross-site scripting was as widespread popular now, usually like you get like what ends up happening is like you go to a website that looks a lot like the website that you meant to go to, like a bank or something. You type in the info of it and then or it just gets it from the cookie because the login info is stored on that cookie. And so there's another website you go into that looks like it, and you can just retrieve the cookie for like a different website. And I at least that was like over a decade ago, that was like an actual ticket that I had to try to do it.
Oh, like session cookie?
Yes, that's
That's
what
like, that's like the main way that shit is stolen.
Yeah.
That's how I bypass two-factor authentication.
Yeah.
Straight to a big code for Microsoft.
Session cookies. Well, and with that, I think I'm going to go ahead and discontinue the recording, the streaming. Oh, thank you. Thank you. I guess go over this one last slide before we stop the streaming. This group of course, like Tech for Troops is great. They give me the space for free. Everything else like is just basically that comes out of my pocket. It's my most expensive subscription, you could say. And this upcoming August, I'm planning to go ahead and renew with Meetup.com for a full year. So I do plan to continue doing this, and like up until August 2026. But with that, I'm going to start asking, like, hey, throw a little something towards if this is something you like. So the meetup cost, like for 1 year, is $300. Like depending on the group sizes, I expect for 1 year to spend anywhere from like $600 to $1,000 for consumable items, and not the non-consumable items that I actually would get to use later, like this beautiful camera. So yeah, but so I put a couple signs out around the room. Appreciate it if I was able to. Thank you. Let's turn this off.